Adding algebraic terms. To add algebraic terms, use the same rules or principles as for adding sign numbers. There are two different types of terms, like terms and unlike terms. Like terms have identical letters and exponents. Like terms can be added or subtracted. Unlike terms have either different letters or different exponents. Unlike terms cannot be added or subtracted. Example 1. Add 7xy to the second power and 5xy to the second power. In order to add algebraic terms, we must make sure that the algebraic terms are alike. As we look at these algebraic terms, 7xy to the second power and 5xy to the second power, we will notice that both of these algebraic terms contains the variables x and y. Not only do they contain the variable x and y, the x's and the y's are raised to the same power. In this particular x is raised to the first power. There's an invisible 1 here, so it's understood to be to the first power. On this side, you also have an x with an invisible 1, which is also raised to the first power. The y is raised to the second power. On this side, you also have a y that's raised to the second power. Therefore, we have like terms because all the variables are the same and the exponents of the variables are the same. Now we can add 7x y to the second power plus 5xy to the second power. In adding algebraic terms, the only part of this expression that we're going to add will be the numbers that are in front of the variable. 7 plus 5. 7 plus 5 is 12x y to the second power. So in combining these like terms, this is a solution that we get 12x y to the second power. Example 2. Add 3ab and 5ab to the second power. In order to add algebraic terms, we must make sure that the terms are alike. If you look at 3ab and 5ab to the second power, you will notice that a is raised to the first power. A on this side is raised to the first power. B is raised to the first power here. But over here, B is raised to the second power. And the only way you can add expression, algebraic expression, you must have variables that are alike, and the variables also must be raised to the same power. So therefore, 3ab and 5ab to the second power are unlike terms, and they cannot be added. Let's go to example 3. 7a to the second power and 2b to the second power. In this particular algebraic expression, you can see that you have this particular problem, this particular part of the expression has an a to the second power. But on this side of this expression, when you're trying to combine, there isn't an a visible at all, so an a isn't in this expression. On this side of the expression, you have a b to the second power, whereas on this side, there's no b. So in this particular expression, the variables are not the same. The exponents are the same, but the variables are not the same. In order to add terms, you must have the same exponent. You must also have the same variable. They cannot be combined or added. Example number 4. Add 4a to the second power plus 3b plus 5c plus d to the second power and 2a to the second power plus 5b minus 2c plus d to the second power. In order to add this expression, we must make sure that the terms are alike. 4a to the second power is over here. We have 2a to the second power here. 3b here, 5b here. 5c here, a negative 2c here. Have positive d to the second power, positive d to the second power here. Therefore, since all the terms are alike, that's on both sides, then we can add the terms. Let's begin by lining these terms up vertically. 4a to the second power plus 3b plus 5c plus d to the second power and 2a to the second power plus 5b minus 2c plus d to the second power. 4a to the second power plus 2a to the second power is equal to 6a to the second power. A positive 3b plus a positive 5b is equal to a positive 8b. A positive 5c plus a negative 2c. Remember, in addition, when the signs are different, you subtract. A positive 5c plus a negative 2c is equal to a positive 3c. A positive d to the second power plus a positive d to the second power is equal to a positive 2d to the second power. And again, remember, when you do not have a number in front of the letter, it is understood that the number is 1. Therefore, a positive 1d plus a positive 1d, again, is a positive 2d to the second power. So the solution to this particular problem, 4a to the second power plus 3b plus 5c plus d to the second power and 2a to the second power plus 5b minus 2c plus d to the second power is equal to 6a to the second power plus 8b plus 3c plus 2d to the second power. Example 5. 5x minus 3y plus 2z minus 7 plus a negative 5x plus 2y minus z minus 3. Let's add these two algebraic expressions, 5x minus 3y plus 2z minus 7 plus a negative 5x plus 2y minus z minus 3. 5x plus a negative 5x is equal to 0. In addition, when you add and the signs are different, you subtract. So we got 0x. When you get 0x, there's no need to write the x, because that's like saying no x or 0x. A negative 3y plus a positive 2y. In addition, when the signs are different, we subtract. We subtract and we take the sign of the largest number. 2 from 3 leaves 1y. The 3 is the largest number. The 3 is negative. Therefore, the solution is a negative 1y. Positive 2z plus a negative 1z. Remember, when no number is present, it is understood to be 1. In this particular expression, the signs are different. In addition, when the signs are different, you subtract. 1 from 2 leaves 1z. Take the sign of the largest number. 2 is the largest, is positive, so therefore it is a positive 1z. A negative 7 plus a negative 3. In addition, when the signs are alike, you add. Therefore, a negative 7 plus a negative 3 would equal to a negative 10. Therefore, the answer for this particular problem, 5x minus 3y plus 2z minus 7 plus a negative 5x plus 2y minus z minus 3 is equal to a negative 1y plus 1z minus 10. Another way to write this same problem is to write it without utilizing the 1. Negative y plus z minus 10. This is another way to write this same solution, because it's understood that when a 1 isn't there, there's an imaginary 1 is present.
We are in Advanced Publishing's warehouse, and we have quite a number of books that teach values to children. They're character education picture books. And behind me, we have a number of pallets of books, and with them, we're going to be demonstrating adding algebraic terms. One of the big issues in shipping books is the volume. How much space does this pallet of books take? And as you remember, volume equals length times width times height. Now here is one box of books. The length of this box of books is 14 inches. The width is 10 inches, and the height is 8 inches. And this pallet of books has 36 of these boxes on this pallet. And we're going to be adding 2 of these pallets together. So 36 LWH, and that's the volume of this entire pallet, plus 36 LWH. 36 plus 36, 6 plus 6 is 12, 4, 3 is 7, 72. Now what we do here, we don't add these variables or these letters. All we do is take these letters and put them beside the numbers we have added. And we're going to be demonstrating why you do this here. But that is the rule for adding algebraic terms. Let's do the math and find out the volume of these 2 pallets of books. 72 times the length, which is 14, times the width, which is 10, times the height, which is 8, equals 80,640. 80,640. Now notice it was inches that we multiplied, so now this becomes cubic inches. But we want to find how many cubic feet are in this pallet of books. So 1 cubic foot is 12 inches by 12 by 12, and that comes to 1,728 cubic inches equals 1 cubic foot. So what we're going to do, we're going to take this number, 80,640, and divide it by 1,728. Divided by 1,728 equals, and that equals 46.67. Equals 46.67, and that is now, it changes from cubic inches because we divided by this number, and now that makes it cubic feet. So that is the volume of these 2 pallets of books. Now what we're going to do is we're going to take 1 pallet of books and find out what the volume is for 1 pallet of books. Clear the calculator. 36 times 14 times 10 times 8 equals, that's 40,320, divided by 1,728, divided by 1,728 equals 23.33. So this equals 23.33 cubic feet. And so this one also equals that, 23.33 cubic feet. And as you can see, 23.33 adding 23.33 equals 46.67, only because we rounded up. This 3's, they just continue, and these 6's continue, so we rounded this to a 7. But you can see, adding 1 pallet of books to another pallet of books, we just take the numbers and add them, and we do not add the variables or the letters. You just take the letters and put them next to the numbers that you have added.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.